In this unit, we're looking at quadratic functions. If you remember from Algebra 2, we would have the vertex form, or in some cases also referred to as a standard form of a quadratic. Now, in this form, of course, x, y represents all of the different points that are going to be part of this curve. Our a value is going to tell us if this is going to be opening upwards or downwards. Remember that the a, if it is a positive number, then that means that our parabola is opening upwards. And if it is a negative number, then our parabola is opening downwards. And then the hk value is the vertex of that parabola, either the min or the max point. So for example, if we have g of x is equal to x plus 2 squared minus 3. Alright, so from this, we know that the vertex, hk, is at negative 2, because remember in our form it's x minus h, so if this is an x plus 2, that h value is a negative 2, and then our k value is here, negative 3. That would be the vertex of this parabola. And we also know that our axis of symmetry goes through that vertex. And it goes through that x value, so we would say that that axis of symmetry, the equation of it, because remember that's going to be a vertical line, that equation is going to be x equals negative 2. Now what we would call general form would be something in the nature of, let's say we have f of x is equal to 2x squared plus 8x plus 7. So basically what we have is, if this is FOILed out and simplified and you combine like terms, that is what then is referred to as general form. Now, general form, there's certain things we can determine by that. This plus 7, for example, would be our y-intercept. We do still have our a value of 2, so we know that this parabola opens upwards. It's x squared, so we know it's quadratic and it's a parabola for our graph. As far as rewriting this into vertex form, first thing we can do is I can take this piece right here and factor out the 2. And so I'm looking at 2 times the quantity of x squared plus 4x, and then I still have this plus 7 here. Now what we're going to do is we're basically completing the square. I'm going to take this piece here. Remember, to complete the square, I take half of that value. So we're looking at 2, and then I have x squared plus 4x. And then to complete the square, again, half of this number, so 4x I divide by 2, I get 2, and then I square that. So I'm saying that this is a plus 2, and then I square that to get the plus 4. Now to keep it balanced, I'm also going to have a minus 4, because we can't just go add a random 4 in there. We'll take care of that minus 4 later, and I still have the plus 7 here. So the minus 4 piece, it is being multiplied by 2. So I'm going to take that out, because remember, to get in vertex form, we're trying to get back to this x minus h squared. So I have a quantity squared. That's what we're trying to accomplish with this. So we have 2, and then I'm going to have just this piece, x squared plus 4x plus 4. I'm now taking this piece out to put over here with the 7. So I'm going to have minus, but it's 2 times that. So that piece I just brought over to here. So now we have, and we still have the plus 7. Now again, That is the whole complete in the square piece. I can factor that. That is our x plus 2 squared. That number, again, comes from that same piece where we took the middle number and divided it by 2. We know that's what's going to be going there. I still have an a value of 2. And now I have, this was minus 8 plus 7. That turns into minus 1. So now we have vertex form. We have our a value of a positive 2. We know it's opening upwards. We have the vertex. We can see is at negative 2 from this value, negative 1. And then again, our axis of symmetry goes through that point. So that axis of symmetry is where x equals negative 2. Now, what if we're given the vertex and we're given a point that our parabola is going through? All right, so what we're going to do with that, as far as rewriting this as a quadratic or in vertex form, first we know that we have y equals a times the quantity of x minus h squared plus k. If we plug in the different values that we know, again, every single point represented is our x, y, so I can plug that in for an x and a y. Vertex, again, is our hk. What we really need to find is our a value. So if I plug in the different pieces that I know, like the vertex, we have a 1 value, so that's going to be x minus 1 squared, and our k is 2, so that's plus 2. Now we have a ordered pair here of 3, negative 6, so 3 is my x value and negative 6 is the y, so we have negative 6 is equal to a times 3 minus 1 squared plus 2. And now we're solving for a. So 3 minus 1 is 2 squared, so that's going to be 4a plus 2 equals negative 6. I'm going to subtract the 2 and divide by 4. A equals negative 2. So then our equation in vertex form is going to be y equals negative 2 times the quantity x minus 1 squared plus 2. Now we also have mentioned here that the vertex of the parabola is our minimum or maximum value. All right, so if we have an equation, y equals 2x squared plus 8x plus 7. Again, here's our a value. A equals 2, so we know that the parabola opens up. And that also tells us that our vertex is a minimum value. Because we know that the parabola is opening upwards, so then our vertex is right down here. That would be a minimum. So another way we can find that is if I take the opposite of b over 2a. Now remember, in general form, what we're saying here is that it's ax squared plus bx plus c. Right? So we have y equals ax squared plus bx plus c. So in this case, our b value is 8, so we're going to take the opposite of that over 2 times our a value is 2. So negative 8 divided by 4 equals negative 2. So then what we have found is what our x value is at the vertex. It's at negative 2, and now we can plug that back into our original. So we have 2x squared, so that's going to be a negative 2 plugged in there, plus 8 times x, plus 7. So then we simplify that. That is equal to -1. So that just tells us that the vertex is at -2, -1, because there's my x and there's my y, which also tells us our axis of symmetry. Again, goes through that point, and the equation for the axis of symmetry would be where x equals -2.